Hi everyone, I'm Mohammed, and by the end of this video, you'll be able to create your own AI agents that can code for you. Imagine assigning tasks like generating and solving a random maze or running 1,000 coin toss experiments to visualize the results, all automatically. We'll start from scratch and build a code developer agent and a code executor agent that collaborate as a team. Then we'll wrap it all up in a Streamlit web application to showcase their teamwork. Let's dive in and make a team of agents work for us. Okay, so we'll do this project in two steps. Initially, we will develop the backend side and then the front-end side, just like the previous videos. In the backend side, we will define two agents. One of them is an LLM agent and is a code developer. It gets a task and develops a code for solving that task. And then the other agent, which is not an LLM, is a code executor. It can just execute the input code and spit out the result. And these two agents engage in a conversation until the task is accomplished. So, for example, I asked the team of these two agents, what is the 17th prime number? And the code developer will write down a piece of code that calculates the 17th prime number and passes that code to the executor agent. And that agent runs the code. Well, if the code is successful, it will just return the result. Otherwise, it will return the error, and the code developer can rewrite the code, can modify it to solve the error. And this goes on and on until we have the answer, and then the code writer, the code developer agent, will return the final answer. So, without further ado, let's start. So let me first define the code executor agent, since it is new in our playlist. The other agent, the code developer, is an assistant agent. We've seen that in previous videos, but this is our first time encountering with the code executor agent. So I would say from AutoGen agent chat import agentchat.agents import code executor agent. And the code executor can do one of the following two options. It can execute the code in the current environment, but there's a slight chance of disaster, because maybe the code does something disastrous, and then our system will be at risk. But the other option is to pass it to make it use a Docker container. So it will run the code in a Docker container, and it will make sure that there is no harm in our current operating system. Even if something disastrous happens, we're safe. We just lose a Docker container. So I also need to install Docker. If you don't know how to install Docker, you can easily search in Google and install it. And once you have Docker installed, you can create a Docker command line executor object. So you should import it from AutoGen x.codeexecutors.docker from AutoGen import Docker command line code executor. So we should initially create an instance of Docker command line code executor. And as you see, the documentation suggests, the default image is a Python 3 Slim image. So it's a standard image, and most of the time it will do your work. But if you need a more specific Python version, you can also pass it your own image. You can create your own Docker image and pass the name. And also you can name the container, but these are not necessary. These are not mandatory arguments. These are optional. Another argument that is common is the working directory. So you can specify what folder to work on for the Docker. This folder will be mounted on your Docker container, and you'll also see it in your system. So I would say create a temp folder and do your stuff there. And I believe this is enough for the Docker command line executor. And now we need to define the agent, the code executor agent. I would call it code executor, and it will be a code executor agent. So we should pass a name. I would say code executor, just like this. And then we should pass the code executor object, which is our Docker object now. And we're good to go now. Okay, if I want to show you how this works, as you see, we didn't pass any LLM, any large language model. So this is not an LLM agent. This just gets an input, finds the block, the code block for Python or Shell, and executes that block and returns the result. So I can say this is my code. Let's say something like this. Print hello world. Yeah, just this one. And now I want to pass this code to the Code Executor Agent. And by the way, just to practice reading the documentation, we want to see how to feed this code or this prompt to our agent. And of course, it shouldn't be this way. It should be presented as a code block. So it should be like this, Python. And yeah, something like this. So let's practice reading the documentation. Well, at the end, we need to call the onMessage function, but let's see. Let's go to AutoGen documentation, and we have this agent chat, and let's go to the API reference. Okay, we have agent chat agents, and as you can see here, we have the documentation for Code Executor Agent. Its base class is the base chat agent, and if you take a look at base chat agent, it has a method onMessages. Yeah, this one. So as you see, it gets a sequence of messages, a list of messages, and also a cancellation token. I will talk momentarily about what is cancellation token, and then it will return the result as a response. So, well, the messages is clear. We need to pass a sequence of messages. Well, right now we have just one message. We have one input. And then it also gets a cancellation token. And the reason for having this argument is that the process for any agent is inherently an IO-bound process, input-output bound from our side, because we don't do the whole process. We just ask a server, such as OpenAI server, or an exterior side, and the processing goes on there, and we don't care about the process, and then we get the result. This is how we look at an agent. It's just a black box agent. So maybe while waiting to get the answer, we decide something else. We want to cancel the process. We don't want to we get the response from that point on. So we need to somehow be able to cancel the process, even when the outer side, the exterior side is calculating and finding the response for us. So this is why we have cancellation token. We create a token there, and then whenever we decide to cancel the operation, we can call this cancellation token cancel method. And as you see, cancellation token is in AutoGen core library. So let me import it from AutoGen core, import cancellation token. Okay. So, and of course, our agent will work in async mode. I've talked about async mode and the concept of async briefly in previous videos. And just to repeat myself, we have two practices of coding. We can do it synchronously or async in the async way. So in the synchronous way, here's what happens. While we're executing a line, we wait there until we have the result, and then we proceed to the next line. But in the async mode, in the asynchronous mode, maybe we have several different processes. They are IO bound, they're input output bound. The bottleneck is not the process for us. The bottleneck is just waiting to get the answer from some exterior side. So here's where the async paradigm can help us. instead of waiting there, we can do other tasks that are not directly dependent on the current task. So this helps us to execute our whole project way faster. And it is the same in the agents world, because we look at agents as a black box. Well, some of our agents, or I can say most of our agents, are LLMs that we just use their APIs, and the core computation is done in OpenAI servers or Google servers for Gemini, for example. So while waiting there, we can do other tasks. Maybe we want to run several agents at the same time, and we don't necessarily need to wait for each of them and then go on to the next one. We can feed all of the agents some inputs simultaneously and wait for the answers. So this is why we want to do it in the asynchronous way. So I need to import the async IO as well, and I need to define a coroutine. Again, a coroutine is a function in async mode. I will call it main for now. And instead of calling a function, I should await them. So I say result equals await code executor dot on messages. And for the messages, well, I need to define a text message. A text message object is the kind of message that travels between different agents in AutoGen. From AutoGen agent chat dot messages, import text message. And the text message needs both content and a source. So here's the content. Content is the code, and role is, let's say, user for now, or it can be anything. And then I need to pass the cancellation token. Cancellation token is a new object of cancellation token class. And in the end, I will print the result. And I need to create an event loop, asyncio.run main function. This will create the event loop for us. Okay, so let me run dev.py. Python dev.py. Okay, so we have an error. Let's see what is the error. Text message, and this is the role. Content is the code. Okay. Oh, sorry, it shouldn't be source. It shouldn't be role, it should be source. So the text message was not, the argument for the text message was not valid. And okay, we have a new error. Container is not running, must first be started. Okay, we need to start the Docker container before using it. So I can say docker.start, and in the end I need to stop the Docker container. So here I would say docker.stop. Okay, now let's see. Again, Docker is not, the container is not running, must first be started. Okay. Maybe I should start it after. Yeah, I should start it after the Code Executor Agent. And this is not the reason again. Oh, the reason is that I should await docker.start. So, and also for stopping, because I'm working in async mode, I cannot just call it. It's an async method. So let's run it now. Okay, we see the answer. The script ran, then exited with an error, and this is the error. Expected indent. Okay, it's an indentation error because it's running a Python code and it's just one line. So this is actually a tab here. We shouldn't have a tab. So let me remove the tab, and now it should be fine. Yep. You see the content is hello world and the code ran successfully. But we don't need to really do this to call the onMessages method from the code executor, because just like the previous videos, we will form a team in the end, and that team will handle all of these operations. So this was just an illustration of how the code executor works. And now we will define the code developer agent. So let me import the assistant agent. So again, as we've talked about it in our previous videos, an assistant agent is an agent that has an underlying LLM, and we can feed it a prompt and it can return the result, the output, based on that prompt. It can also access some tools, but today we will not be working with the tools. We will just use the LLM and define the assistant agent with the name of code developer, and then that agent will be in conversation with the code executor. So here's the code developer agent. It's an assistant agent, and the name will be code developer, and then I need to specify a model client. This is actually the underlying LLM that this assistant agent will use. So let me define the LLM here. For that matter, I need to import the OpenAI client from AutoGen extension .agents, .models .openai, import OpenAI chat completion client. So this will be my model, an OpenAI chat competition client, and I need to specify the model. I will use an O3 mini for today, and I need to pass my API key, which will be inside this API.text. So let me read it. Open API.text.read.strip. Well, that read reads from that file. That strip makes sure there's no extra space in the end, because sometimes when you save a file, there is just one extra line, an extra empty line that can cause some errors if you pass it to the OpenAI servers. And again, please don't copy and paste your API key directly here. Try to keep it in a separate file and try not to push that file in a GitHub repo. Or you can also define a system variable for your OpenAI API key, but this is good enough. And now we should pass the model as model client to the code developer, and we need to specify the system message, and this will be my system message. Okay, you are a code developer agent. You will be given a task, and you should develop or write code to solve the task. Your code should only be in Python or shell. At the beginning, you should specify your plan to solve the task. Then you should write the codes to solve the task. And I should also say that you should always write your code in a code block. You should always write your code in a code block with language Python or shell specified. You should write one code block at a time and then pass it to the Code Executor Agent. I haven't introduced the Code Executor Agent, so let me do it here. You'll be given a task and you should write code to solve the task. You are a code developer agent working with a Code Executor Agent. And yeah, you will be given a task and you should write code to solve the task. Okay, it's fine now. You should write one code block at a time and then pass it to the Code Executor Agent. Once the Code Executor Agent executes the code and you have the results, you should explain it and then exactly say terminate. We use this terminate expression to terminate the chat because we don't want the chat to go on and on when it's finished. Okay. Now we have the Code Developer Agent and the Code Executor Agent. The only thing remaining is to define their team. So as you can remember from our previous video, we can have several kinds of teams in AutoGen. The one we'll be using today is the RoundRobinGroupChat. So from agent chat, AutoGen _agent chat dot teams import RoundRobinGroupChat. And what is a RoundRobinGroupChat? It's a team in which there are some agents, some participants, and they will deterministically behave in the team. So for example, we have the first agent, then we feed the output to the second agent, then to the third agent, and then again first, second, third, first, second, third, or to any number of agents that are present. So in our current team, we have only 2 agents. So initially, the code developer will develop something and will pass it to the code executor, and then it will return the result to the code developer, and then again code executor, and so on and so forth. So let me define the team here. Team is a RoundRobinGroupChat. We need to specify the participants. So it will be the code developer and the code executor. And we need to define the termination condition to be able to terminate the chat once we have the result, once the code developer says terminate with capital letters. So I need to import the code termination object, the code termination class from AutoGen. I guess it was in AutoGen core dot, let me see, dot models, or dot base maybe. or AutoGen agent chat.base import. Yeah. No, I can't remember. Let's check the documentation. So how can we find it? We should see the team part of the documentation. Let me go back here. We have the agent chat, and we have the teams, then the round robin group chat. It's okay, we need the termination condition, right? And for the termination condition, I can see this is the class I need, text mention termination. Yeah, it is inside AutoGen agent chat.conditions. .conditions import text mention termination. Okay, so what this class does is whenever a particular expression is mentioned, it will terminate the chat. The name is self-explanatory. And what is that text, that expression? It's terminate with capital letters. And do I need to specify anything else? Yeah, the maximum number of turns. So, I want to say at most you need to have the chat going on in 10 turns, not more than that, because I don't want the chat to go forever. Maybe something's wrong and I want to stop it after a while. And now I should call the team. So I would say result equals await. I can call the team in several ways. We've seen it in previous videos. I can say, there is a run method. The bottleneck, the downside of the run method is that we've seen this in the previous video for the agents engaging in a debate. So whenever we use the run method, the problem is that we should wait until the end of the chat. So maybe it goes on for 10 turns. We should wait until the last moment, and then we have all the results all together. But we want to see the progress gradually. We want to see how the agents respond, one after each other, and somehow, not in exactly real time, but somehow in real time. I don't want to wait until the end. So here's what I should do. I should iterate. So I need an async for message in team.runStream. So this is a generator, and just briefly, what is a generator? A generator is a function that whenever it returns or yells something, it stays there, and when we call it again, it continues. So how can this concept help us now? The agents start whenever the first agent yells return or yells some response, we will have it, and then we call it again, and then it passes the message to the second agent, and then it yells the result again, and then we go on and go on. And we can, by doing these iterations, we can gradually see what the agents are doing. Okay, and the run string takes a task, and task can be a string. So what is our task for the team? Well, let me define a variable for task here. I can say, what is the 17th prime number? And I will pass this task as the task argument of runStream method. So this message can be one of the following two types. It can be a text message. That is, as I said earlier, that is the type of the message that the agents communicate between each other. And it can also be a task result object. And when is it a task result object? In the end. When we have all the results, when the chat is complete, it will return a task result object. So I should handle them differently. I should check if message is an instance of task result. And I need to import task result as well. So I would go here and from AutoGen agent chat dot I guess it was base import task result. Yeah. Even if we didn't know, if we didn't remember which class to import task result from, we could have gone to the documentation and we could check. Let's go to agent chat, and we have the team, we have the round robin group chat, and again this is a child of the base group chat, and the base group chat has the run method. We can see it here. In the end, it returns a task result, and here's the task result from AutoGen underline agent chat dot base class, base library. Okay, so if message is a task result, maybe I can just print out the reason to stop the chat. Was it because the maximum number of terms has reached, or maybe the termination expression has been mentioned? So let's see what it was. I would say stopping reason is message dot stop reason, and else, this is the case that message is a text message object. I would say print message dot source, and then a column, and then message dot content. And after all, say print task completed. Let's see. Let's run this code. You see the user message, what is the 17th prime number? And done. So here's the code developer. Plan, I'll write a Python script that finds the 17th prime number by iterating through natural numbers and checking for primality. Once computed, the result will be printed. And this is the Python code, but it hasn't waited for the code executor. It has, the code developer has thought that this is the right code and it's enough, and then it has terminated the chat. This is not good. So I should change the system message. Okay. Pass it to the code executor agent. Once the code executes the code and you have the result, you should explain it and then exactly say terminate. Let me add some more detail. Never say terminate before the code executor agent has returned the result, the execution result of your codes. Okay. Of all your codes, and you are sure there was no error while executing. Okay. Maybe this helps. Let's see. Okay, yeah. Now it has asked, please execute this code. And then this is the code executor's output. The 17th prime number is 59. And then the code developer says, the script correctly computed that the 17th prime number is 59. And then it says terminate, and we're good. Let's test it with some other task. I can say, let me comment this one. I can say sum the numbers from 1 to 100 maybe, and print the result. Just this one. A fairly easy task, but I just want to make sure everything's all right. Yeah, you see the code is so easy. Sum of range of 1 to 101 and print it. And the code summed the numbers from 1 to 100 using the built-in sum function with the range function and printed 50/50. Okay, so we have a working pipeline now. We have a code developer agent and a code executor. You know, this was really what most of us developers were doing back in maybe 2023 and the end of 2022 when ChatGPT was initially released. In many times I've seen many guys that pass a prompt. At that time they passed a prompt to ChatGPT, and ChatGPT would then develop a code, and then they would copy and paste it into their interpreters, their IDs, and if the code was executed successfully, then they were happy. Otherwise, they needed to copy and paste the error themselves into ChatGPT again, and they would ask, okay, what's wrong with this error message, and then ChatGPT would address the error. It was a tedious process, and I really hated it. I would try my best to avoid it because maybe I'm old-fashioned in somehow, but I strongly believe that a developer should be strong enough to deal with the errors himself or herself. But of course, in routine tasks, in daily tasks, we can trust LLMs and it's fine. But in critical tasks, you should never trust an LLM. You should supervise it pretty intensely. Okay, so we have a working pipeline now. Let me ask for a more difficult task. So I want to somehow see the law of large numbers in statistics. So toss a coin 1,000 times and print the number or the ratio of heads to all tosses. Toss a fair coin maybe. Let's run it and see the result. Okay, this is the user's message. This is the code. You see it. And yep, ratio of heads is 0.487, close to 0.5. Fair enough. And maybe I can say 1,000,000 times and see what happens. And by the way, whatever code that the developer creates or comes up with is saved in the temp directory, since we've specified temp as the working directory of Docker. Okay. Now I'll write the code in Python. Oh, it hasn't waited for the code executor again. Maybe I can change the system message again to put more emphasis or do some pretty quick prompt engineering. So once the code executor agent executes the code and you have the results and the code was executed successfully, then you should explain it, and then you should explain the code. I want to put emphasize and implicitly state that the code execution should return the result. The code execution result. Okay. You should write one code block at a time and then pass it to the code executor agent. Once the code executor agent executes the code and you have the result and the code was executed successfully, you should explain the code execution result and in the end exactly say terminate. Never say terminate before the code executor agent has returned the execution results. Okay, let's see. This is the task, this is the code, and now we have the code executor result. Yeah, pretty close to 0.5. And let me give it a more difficult task this time. Instead of doing this experiment only once, I want to say toss a fair coin respectively from 10 times to, let's say, to 1,000 times with steps of 10, and generate a beautiful plot of the ratio of heads in each experiment. Yeah. And in the end, save the plot as plot.png. Okay, so I have this task now. Let's see if it can handle it or not. Okay, you see the code has been developed, and now NumPy was not installed. I expect the agent to use pip install to install the NumPy now. Yeah, you see. And also we had the same error for matplotlib. Okay, it didn't install NumPy. Instead it used random library, but then it ran into a newer error for matplotlib not being installed. Then it used shell to pip install matplotlib. And now I believe the code executor should run this shell script code and should install matplotlib. Yeah, it was fine. You see the script ran. This was the message. The script ran but produced no output. It means that it was successful. And then it ran the code again. And this is the code executor. Again, no output. It means that it was successful. And if I go to temp, I can see this is the plot. Let me show it to you. Yeah. And this is a beautiful illustration of the law of large numbers. You see, as the number of experiments, the number of coin tosses gets increased, we get closer to 0.5. So this is already good enough, I believe. So now we have a perfectly working backend, and it's time to develop the front end, the web application using Streamlit. So let's see. I will do the front end side in a new script. I will call it app.py. So obviously we need to import Streamlit as st. And just as a quick recap, Streamlit is a framework to develop web applications. It facilitates the process. You can develop a pretty beautiful and standard web application pretty fast using Streamlit. So let me specify the title. I would say my developer agent. And I need a text block, a text area to get the task. So let's say task equals sc.text area, and okay, this is the label, task, and we can have a default task. Let's just copy one of these tasks from the dev.py. So for now, let's just copy this one. It's pretty easy. So this will be the default task. Default task. Okay. And I will also have a button here, a run button. Whenever it's clicked, the clicked variable will be true. And for now, I will also have a container, an empty container here to visualize the chat. So I would say chat is st.container. And if the button is clicked, well, I haven't connected the dev.py to app.py yet, but just for now, let's say chat.empty, and with chat, just write running for now. And to run the Streamlit app, you cannot say Python app.py. You should say Streamlit run app.py. Oh, sorry. App.py. Okay, so you can see the title here, the task here, and when I press run, it says running. So now it's time to connect the backend side to the front-end side. Let me stop the code. And just the same way we did this in our last video, I need to make this dev.py more modular. So instead of having a main in which we do all the things, I like to keep these separated, keep the team configuration separated from running the team. So let's define a new coroutine, async dev team config, and the team needs, we don't need any argument here. We will pass the task later. So I will just copy from the beginning of the main to here, and also to the team definition. Okay, I will copy these scripts to the team config, and in the end I only care about the team, so let's return the team. I can also move this Docker start in the next coroutine. Instead of having main, I would rename it to run, and it gets a team and a task, and it runs the task. And you know, since I need to work with the Docker, I need to start Docker inside this run because this is more logical. I don't need to start the Docker command line from team config. It's better to do it whenever I have a task and I need to run the team. So the team config returns both the team and the Docker code executor object. And here I will pass team, Docker, and task. So doing this, let's also move these tasks outside the run. I can define another coroutine here, a main coroutine. I will have the task here, and then I would say team and Docker will be defined from calling team config. And after I have the team config, I can run the team config, the team Docker and task. But this will work right now, but this is not what I was hoping for. Inside my app.py, I want to do this in async mode as well. I want to gradually visualize the chats. I don't want to do them, I don't want to visualize them once I have all of the chat. So here's how I would do it. I will define an async generator here. I will change the run. I will modify it to be an async generator. And this way I can iterate over this generator inside my Streamlit app. And I will visualize the chats once I have every dialogue. So, I start Docker here, and then for message in run stream. Okay, I will define this as message MSG, and instead of just printing it, I will yield the message, the MSG. Same here, I will define this string as MSG and I will yield it. And in the end, I will stop Docker. And yeah, instead of awaiting like this, I can now say for message in, and it should be async for because I'm running it inside a coroutine. Async for message in run team Docker and task. Well, I need to do absolutely nothing because I'm printing it inside the run coroutine. So let me run dev.py. It should run successfully. Okay. Yeah, it is running, we can see. It developed an initial piece of code. It had library issues. NumPy was not installed in my Docker container. And then it installed, again, it used random, and then it installed Matplotlib, and then we have the result. Oh, it's still running. Okay. But I don't need to run that really. I know it works. And the only thing I care for now is that dev.py is a standalone code. It can run, independent of app.py. And now I can use these two coroutines, the run and the team config, inside app.py. Okay, so let's say from dev.py, from dev import team config and and run. And now I can, inside this if statement, whenever the button is clicked, I would say chat.empty, clear the chat container, and then I would say inside the chat with chat. Okay, I need to define a coroutine now. So, and by the way, let's do this before the chat context manager, the with chat statement. So I would say async def run task, and it gets task. And then I would say team and Docker will be specified from team config, and then async for message in run team Docker and task. And okay, now I would say, inside this coroutine, I would say with chat, and for each message, if the message is from the code developer, I want to display it differently with a separate avatar, and if the message is from the code executor, I want to display it with a different avatar. So let's say with Streamlit sc.chat message, it's a component to visualize the chat. It gets a name. I would say this is for AI, and I can pass an avatar, or I can not pass anything, because AI is a defined expression in Streamlit chat message. It has its own avatar. So with sc.chat message from AI, sc.markdown that message. This makes sure that the message is formatted as a markdown. And then, and I should do this if I'm sure that the message is from the code executor, the code developer. So I would say if message dot starts with code developer, in that case, display that message as AI message. And if the message starts with code executor, then display it as a user, and yeah, st.markdown. I guess we're fine now. I just need to create an event loop. So import asyncio. And outside this coroutine, I can say asyncio.run, run task with my task. And let's see what we have so far. Streamlit run app.py. Okay, let's run. Okay, this is the code developer. This is the plan. This is the code. This is the code executor's result. And yep, this is the code developer result. The code found that the 17 prime number is 59. This is the explanation, and we're done. Terminate. Okay, so I have a pretty working UI now, a pretty working web application now. Just out of hobby, I would like to add this option to visualize an image inside this chat, because right now if it produces an image, I cannot see it inside the chat dialog. For example, if I say plot the first 20 prime numbers as a beautiful chart and save it as prime.png, it will work, it will save it, but it will not visualize it inside the chat dialog. So let's see. Yep, this is the code, and then it has used matplotlib. It wasn't installed. It is trying to install it now. And okay, this is the answer from Code Executor. It has successfully installed matplotlib. We have the code now. I guess we have an error again. Yeah, exited with an error. It was for Seaburn Dark Grid. The file was not found. So then the code developer revised the code, and now the plot saved as prime.png successfully. So we have the plot now, but it is not displayed here. Of course, I can take a look at it at my VS Code, and you see it is correct. We have some plot, but I want to display that image inside my chat dialog. So in order to do that, I need to somehow get aware whenever an image is generated. So maybe I can add something I can modify the system message of the code developer. So before saying terminate, I wanted to declare that it has generated an image in a structured way. So once the code executor agent executes the code and you have the results and the code was executed successfully, you should explain the code execution result. Okay. You should then, if an image has been generated, you should then exactly say something like this: generated and file name. Like, let me give it an example. This is somehow a one-shot learning. Generated plot.png, something like this. And in the end, exactly say terminate. Okay. Now I expect it to say something like this. It should include this expression, and then I can visualize it. I can check the messages. Once I have that pattern, I can fetch the file name, the image name, and display it. So I can say, I have the message here, and I will say if generated in message, I need to fetch the file name. The file name would be message.split from generated. So, and the first, whatever comes before generated will be index 0. Whatever comes after generated column will be index 1. And I need to I don't need to strip it. I need to split it again for spaces, because maybe there is some space after that. I can even do it this way. The default value is to separate by spaces. And then I need to get the first element, because after this part is executed, I have whatever comes after generated colon. Well, the immediate expression will be the file name. So I will split it from space and get the first element, which is the immediate expression after generated. And then I can display it using scimage. And of course, this is located inside the temp folder. My agents aren't aware of that, so I need to take care of. I need to make sure the path is correct. So I should say scimage is os.path. Join temp with file name. Or if I want to do it more professionally, I should first check if that file exists. So I can say file path will be os.path.join temp and file name. Then if the path exists, do it this way. If the path exists, display it. Otherwise, declare that this file was not found. And just to make my application look more professional, I can use a spinner object. Whenever the agents start working, I can say with st.spinner running. You will see there will be a rounding circle. So And once it's done, that spinner will disappear. Okay, so let me run the Streamlit app again. And let me copy the coins task. Where was it? It's here. Okay, let me copy this task. And I don't need to keep it in several lines now. Okay, this is good. Run. You see, this was the spinner object. It's at the bottom until all of the chats are done. I'm seeing a particular behavior now. Matplotlib was not installed, it got an error for that. But now instead of doing it with the usual shell script way of doing pip install, it is adopting a different approach. I don't like this kind of approach. This code isn't that clean. So I can specify in the system message of code developer that whenever the library isn't installed, you shouldn't do it this way. You should use shell script. But anyway, you see, we have the image now. So right now we have our chat, and in the end, since we had an image, we can see it. So right now we have a team of agents, a developer, a code developer agent, and a code executor agent. And we can give them, many of our daily tasks, daily development tasks, and they can solve the task for us. So one current limitation of our approach is that, we have a maximum turn variable. We have this max turn. 10 is relatively small. Maybe I can set it to 40, because if I have a more sophisticated task, it will definitely take more than 10 turns to accomplish it. And I also would like to specify that if a library wasn't installed, use shell script to pip install it. So let me also specify that. And if the code executor agent returned an error due to the library not being installed, you should use shell script code block to pip install it. Okay, this will make sure it will never again install the library inside the Python code. And now I would like to give them a more difficult task. It is interesting to me. Let's see if it can handle it or not. So I would say generate a random maze. Yeah, let's generate a random maze and then solve it and then visualize it with an animation and use a path finding algorithm to solve it and display the solution step by step using animation and save it as maze.gif. Okay. Let's see if it can handle it. And by the way, while we're waiting, you can always change the appearance of your system. Right now my theme is dark, but maybe you would prefer light. Okay, this is the code developer plan, and this is the code, and this is the solution function, and we have the create animation. NumPy, Matplotlib, and ImageIO are not installed, and you see it is now using shell to install all of them. Again, we have this code. We have an error. Again, we have an error. It has revised the code. And it was solved and saved. But the GIF isn't that clear. Let me check it. No, I don't like the current version and it's not working. So one limitation of our current approach, you can see it already, is that we haven't specified a role for a human to, intervene and send a feedback. We can always start from scratch. We can say, we can run this again and we can maybe modify the prompt and try to improve it. Generate a random maze and use a pathfinding algorithm to solve it and display the solution step by step using an animation. It should have the whole maze and a red dot that starts from top left to get to the right bottom, and the trajectory should be displayed gradually. Save the animation as maze.gif. Okay, let's run it again and see if it works. Again, we have a problem with NumPy not being installed. Now we have a problem with Matplotlib not being installed. It is now installing Matplotlib and Pillow. We have the code again, the revised code. Again, we have an error. It's just like a human developer. We usually do the coding and then we have some errors along the way and then we try to address the errors. Okay. Yeah, you can see. This is so beautiful. I really like this version. And let's see if the dot can get to the right bottom. Yeah. This is good. Okay, so we've seen how to start from scratch and develop a team of a code developer and a code executor agents, and how they can help us accomplish a programming task. So I hope you enjoyed this video. I strongly encourage you to do the same project, try to do it yourself from scratch without consulting this video or the documentation. Of course, watch this video, you're more than welcome to watch it carefully, but then it should be all you and the internet. So if you want to be a strong developer, you should start from scratch. Whenever you face an error, you should try to address it by reading the documentation and reading documentation, asking ChatGPT, for example. And the only thing that matters is that in the end, you should be able to do your project. Okay, if you're thinking of a better application of agentic AI, a better and more interesting task in which agents can help us, please feel free to comment it for me, and I will definitely record some tutorials on the interesting recommendations. I hope you enjoyed watching this video. Until the next time, take care.